graphical representation of motion. Why do we use graphs? It is because graphs are more convenient to present and visualize data. For example, we've seen a cricket match where the run rate of a team is represented as a graph, a bar graph with respect to the overs the team has played. So it is very convenient to represent the data in terms of a graph. Now, in motion, we represent data in terms of line graphs, which depends upon certain physical quantities such as velocity and distance with respect to time. Distance time graph, a graph between distance and time, that is time in x-axis and distance in y-axis, is called a distance time graph. When an object is in motion with respect to time, it can be represented in a distance time graph. The distance time graph can be used to represent various types of motion such as uniform motion, non-uniform motion, etc. We know that uniform motion is whenever the object travels equal distance in equal interval of time. Therefore, the graph that we get for a uniform motion is a straight line. Uniform motion is nothing but uniform speed or uniform velocity. Why? Because change in distance with respect to time is nothing but what? Speed. Therefore, the graph representing uniform motion is same as uniform velocity graph. Take this graph as an example for uniform velocity. Now, how can you find the velocity from this graph? Let us see how can we find the velocity from this graph. Consider 2 points in the line A and B. Draw a line parallel to y-axis from A and parallel to x-axis from B. The point that touches x-axis and y-axis gives you the corresponding time and distance at these points. Similarly, try to draw parallel lines to y-axis and x-axis from point B. Therefore, you get the corresponding time and distances at the point B. Now, we know that if the object is traveling from A to B, then the distance covered will be what? S2 minus S1. And what will be the time that it takes to cover this distance? It will be T2 minus T1. We know that velocity is nothing but distance covered by time taken. Therefore, from the graph, you can derive the velocity that the graph represents. We'll try to plot the data in the graph. At 0 seconds, the distance covered is 0. At 2 seconds, the distance covered is 1 meter. It comes somewhere around here. At 4 seconds, the distance covered is 4. At 6 seconds, the distance covered will be 9 meters. At 8 seconds, the distance covered is 16 meters. At 10 seconds, the distance covered will be 25 meters. And at 12 seconds, the distance covered will be 36 meters. Now, when you combine these points into a line graph, you get a curved line, which represents a non-uniform motion. Now, this data that is given is a representation of a non-uniform motion. Always remember this. Whenever a distance time graph is giving a curved line, then it is representing a non-uniform motion or a non-uniform velocity. Now, whenever a distance time graph is representing a straight line, then it is representing a uniform velocity or a uniform motion.